Charge Crank System Diagnostic. The vehicle's charging and cranking system functions as a unit. Each component of the system is dependent on the other components in order to function properly. Because of this, it's very important to troubleshoot the entire system. Changing components of a system may not correct the problem. Even if the system appears to work after a component is replaced, the actual cause may not have been corrected, and the same problem can reoccur. Warning: the vehicle will have power going to the components during the diagnostics. Follow safety precautions, including wearing safety glasses and chocking the tires to prevent serious and permanent injuries. Batteries. Start the diagnostics of the cranking and charging system with the batteries. Remove the battery box cover to gain access to the batteries. Inspect the cables to make sure they're tight and free of damage and corrosion. Replace or repair any problems found. Make sure the batteries are properly strapped down in the battery box. Make sure that all the batteries in the pack are the same manufacturer, rating, type, and age. Visually inspect the batteries for physical damage. Before testing the batteries, make sure that the surface charge has been dissipated. This can be done by turning on the headlights for 2 to 3 minutes for each battery in the pack. Therefore, if you have 4 batteries in the pack, you should leave the headlights on for 8 to 12 minutes to dissipate the surface charge. Let the batteries rest for 2 to 3 minutes after turning off the lights, so that the voltage will stabilize before testing. Some electrical testers are capable of testing the batteries in the pack. If using one of these testers, run the system or battery pack test and follow the prompts. If the battery pack passes this test, you may move on to the cable drop test. Otherwise, disassemble the battery pack and test each battery separately. If your electrical tester is not capable of a battery pack test, or if the battery pack failed the test, you'll need to break apart the battery pack and test each battery separately. Attach the lead cap onto the battery terminals and make sure they're tight to ensure a good connection to the pads of the battery. Connect the main red clamp to the cap on the positive battery terminal and the black main clamp to the cap on the negative battery terminal. Run the battery test as prompted by your electrical tester. Perform this test on all the batteries in the battery pack. If the battery pack fails the state of charge portion of the test, the battery will need to be charged and retested. Refer to the battery manufacturer's documentation for charging instructions. A battery needs to be at 75% state of charge or greater. A lead-acid battery at 75% state of charge would have an open circuit voltage of 12.45 volts at 70 degrees Fahrenheit or 20 degrees Celsius. A fully charged lead-acid battery will have an open circuit voltage of 12.65 volts. Other battery types, such as AGM and GEL, will have different ratings. Refer to the battery manufacturer's specifications for details. If the battery cannot hold the proper charge or fails the load test, then the battery will need to be replaced. Replace the battery with a battery from the same manufacturer with the same rating, type, and age. If this is not possible, you'll need to replace all of the batteries in the pack. After testing all the batteries, reassemble the battery pack. Clean all connections prior to reconnection to ensure low resistance. Cranking cable drop tests. After the batteries have been checked, you'll need to measure the resistance in the cables between the batteries and the starter. To do this, a voltage drop test is performed. To do a voltage drop test, connect the main cables of your electrical tester to the positive and negative terminal on the starter. Connect the smaller sensing cables to the positive and negative terminals in the battery box. Run the cable drop test for the cranking system. If prompted, make sure the load is set at 500 amps. A voltage drop of 0.5 volts or greater indicates high resistance. Check the connections and troubleshoot the cables to determine the source of high resistance. Replace any cables with high resistance. Ignition circuit. Disconnect the ignition wire from the starter. This will prevent the truck from turning over while performing this test. Set the voltmeter to DC volts, and then connect the positive lead to the ignition wire and the ground lead to the vehicle ground. Attempt to start the vehicle and read the voltage at the ignition wire. If you're not receiving battery voltage, you'll need to troubleshoot the ignition circuit. Please refer to the truck's electrical schematic to understand all the different components in the system so you can understand what needs to be tested. Starter. If the proper battery voltage and ignition signal are getting to the starter and the engine is able to spin freely, then you should replace the starter. When replacing the starter, check to see if there's a spacer between the starter and flywheel housing. If a spacer is present, it needs to be transferred to the new starter. This spacer is engine-specific and needs to be transferred even if changed between different starter manufacturers. Before installing the new starter, inspect the ring gear for excessive wear. If the teeth are worn, you'll need to replace the ring gear. Refer to the installation video for more details about replacing the starter. Alternator cable drop test. The batteries need to be tested and fully charged prior to performing the voltage drop test across the cables. Inspect the cables and the connections for corrosion, loose connections, swelling, or any other damage. Connect the red main connector of the electrical tester to the alternator's B+ terminal. Connect the black main connector of the electrical tester to the alternator's B- terminal. Connect the smaller red sensing cable to the battery B+ and the smaller black sensing cable to the battery ground. Run the alternator voltage drop test and enter the alternator's output current rating as the load. The voltage drop across the positive and negative cables together should be less than 0.5 volts. A measurement greater than 0.5 volts indicates that there is high resistance, and you'll need to troubleshoot the cable and connections to determine the source of the high resistance. Alternator test. Connect the red main connector of the electrical tester to the alternator's B+ terminal. Connect the black main connector of the electrical tester to the alternator's B- terminal. Some testers will have an amp clamp. The amp clamp will need to be zeroed prior to connecting it to the harness. When connecting the amp clamp, make sure you hook it around all the B+ cables connected to the alternator. The amp clamp should be connected only to the positive cables, with the current flow direction pointing away from the alternator. You'll get an inaccurate reading if you put the clamp around a harness containing both positive and negative cables. Run the alternator test. This will be part of the system test on some electrical testers. Follow the prompts to start the engine, idle the engine, rev the engine, and turn on and off vehicle loads, such as heat fans and headlights. Do not use intermittent loads, such as the windshield wipers. The tester will check the alternator's regulator, rectifier, and output to determine that it's functioning properly. Replace the alternator if you determine that it's malfunctioning. Refer to the installation video for more details about replacing the alternator.